Well, hello there and welcome back to another video. So today I want to go back in time a little bit and not just to Advent of Code, if I can type in the correct place, not just to Advent of Code 2022, which I have already completed, but 2021, which I haven't completed. As you can see, I'm missing day 24. And well, it's been a year and 9 months since I've done this, so I don't really remember what was going on like in the previous days before this one. I just remember that this Advent of Code had the plot of like you going down in a submarine, and well, I kind of feel bad for never having finished this, but day 24 was, I don't know, too challenging for me, I guess. And today I want to give it another try and see if I can do something. Because basically, I didn't even try. When I read this thing a long time ago, I just read it and got like paralyzed. You know, like paralysis by analysis. It's like I was thinking ahead of what I should do, and it seemed kind of impossible or something. Like it seemed too difficult, and I didn't even try. So I don't know. I want to this time not actually think about the whole thing, but just give it a try, the simplest thing, and see how it goes. It's probably not going to work in the first try, but maybe I can learn something along the way and try to understand things a bit better. So that's the idea for today's session, and it's I want to take note of the time so I don't do too long of a session. So the idea would be to just try the simplest thing possible and see where it doesn't work, if it doesn't, and maybe if it does work, I don't know, celebrate. But okay, let's remember what this thing was about. I have a memory of what this is about, but I don't actually remember the whole thing, or the details, I guess. Okay, so day 24, arithmetic logic unit. Let's bump the font size a little bit. Arithmetic logic unit. Magic smoke starts leaking from your submarine's arithmetic logic unit. ALU. What is magic smoke? It's a humorous name for the classic smoke produced by severe electronic overstress on electronic circuits or components. Okay, so this is basically when some things burn up. Without the ability to perform basic arithmetic and logic functions, the submarine can't produce cool patterns with the Christmas lights. Oh no, that seems very important. It also can't navigate or run the oxygen system. Okay. So we have been without oxygen for like almost 2 years. I guess we have probably died in that time, but well. Don't worry though, you probably have enough oxygen left to give you enough time to build a new ALU. The ALU is I actually don't know if ALU is pronounced as ALU, but I will be pronouncing it that way. It's a 4-dimensional processing unit. It has integer variables w, x, y, and z. These variables all start with the value 0. The ALU also supports 6 instructions. Okay, 4-dimensional processing unit. I wonder if that 4-dimensional thing is a hint. I think I didn't catch that hint in the past. So maybe we have to interpret some things as 4-dimensional shapes or something, or like a 4-dimensional vector of these numbers. Interesting. So now we have a sort of a specification of what the instructions of the CPU or the arithmetic logic units are. I do remember about this thing, or have a big idea about that. Imp A reads an input variable and writes it to the variable a, add a and b, adds the value of a to the value of b, then stores the resulting variable a. Okay, multiplies the same thing, then stores the resulting variable a, div, same thing, truncate the result to an integer, then store the results in variable a. Okay, so integer division basically. Mod a and b, divide the value a and the value b, then store the remainder in variable a. This is also called the modulo operator. Equal a and b, if the variable a and b are equal, they store the value 1 in variable a, otherwise store the value 0. Okay, so pretty standard. There is no there's no subtraction, so I guess we can use unsigned integers. I was opening the Wikipedia module page because I wanted to see if here it says reminder. So if it's all integer, if it's all positive integers, then modulo and remainder is the same. So we don't have to worry about that. In all of these instructions, a and b are placeholders. A will always be the variable where the result of the operation is stored, one of w, x, y, or z, okay. While b can be either a variable or a number. Numbers can be positive or negative, okay, so scratch what I said about only positive, but will always be integers, okay. So if they can be negative, I guess we have to know if the modulo operator is actually like modular math or the remainder, because here it says actually both things. Okay, the ALU has no jump instruction. If in an ALU program, every instruction is run exactly once in order from top to bottom. Okay, that is a great simplification. The program halts after the last instruction has finished executing. Program authors should be especially cautious. Attempting to execute div with b equals 0 or attempting to execute mod with a less than 0 or b less or equal than 0 will cause the program to crash and might even damage the ALU. These operations are never intended in any serious ALU program. Okay, that's interesting. So no, we don't have to worry about remainder or modulo differences. We probably will have to check these conditions. For example, here is an ALU program which takes an input number, negates it, and stores it in x. Okay, so this reads into x and multiplies x with 1, so that is, negation. Here's an ALU program which takes two input numbers, then sets z to 1 if the second input number is 3 times larger than the first input number, or sets z to 0 otherwise. Okay, so it reads z and x, then multiplies z by 3, and then compares z and x. Okay. Here's an ALU program which takes non-negative integer as an input, converts it into binary, and stores the lowest ones bit in z, the second lowest 2's bit in ed, the third lowest 4's bit in x, and the fourth lowest eighth bit in w. So how does it do that? It reads w, it adds, this is interesting. So copying, like storing a value, since since all these variables start at 0, this is the same as assigning w to z. Interesting. Then it does mod z with 2, so it takes the remainder and stores it into z, and divides w with 2. So z keeps the ones, like the least significant bit. Then I guess that's the same, divides w with, it keeps the w and then that's the same with y and keeps the reminder there, and that's the same with x, and then that's the same with y, with w one last time. Once you have built a replacement ALU, you can install it in the submarine, which will immediately resume what it was doing when the ALU failed, validating the submarine's model number. To do this, the ALU will run the model number automatic detector program, monad, your puzzle input. Okay, that's kind of a funny reference to the infamous M word in programming. I mean, what an ugly sounding word that is, right? Sounds too much like gonad. But luckily, like no sane person would choose to use that name for any serious project or even, I don't know, concept in programming. Luckily, this is just a joke inside of this, in this puzzle. Okay, so this monad or M word program is our input. Okay, and it's for validating the model number in the submarine. Submarine model numbers are always 14-digit numbers consisting only of digits 1 through 9. The digit 0 cannot appear in the model number. Okay. When Monad checks the hypothetical 14-digit number, model number, it uses 14 separate input instructions. Hello, Simona. The cat is on my lap. Okay, where was I? Uses 14 separate input instructions, okay, each expecting a single digit of the model number in order of most to least significant. So to check the model number 1357942689999, you would give 0 to the first input instruction, 3 to the second input instruction, 5, and so on. This means that when operating Monad, each input instruction should only ever be given an integer value of at least 1 and at most 9. Okay, then after Monad has finished running all of its instructions, it will indicate that the model number was valid by leaving a 0 in variable set. However, if the model number was invalid, it will leave some other non-zero value in set. Okay, so the set variable, the value of the set variable at the end of running the monad program will indicate if the model number was valid or not. Monad imposes additional mysterious restrictions on model numbers, and legend says the last copy of the monad documentation was eaten by a tanuki. Tanuki are those like raccoon things from Japan. Yes, they actually call Japanese raccoon dog. Okay. They seem a bit more cute than raccoons though. Okay, so we have no documentation of the monad thing. You will need to figure out what monad does some other way. To enable as many submarine features as possible, find the largest valid 14-digit number that contains no zero digits. What is the largest model number accepted by monad? Okay, so that is the puzzle, and the input, well, looks like a series of instructions, and there should be 14 input instructions. So if we look for this, highlight all, yeah, and it looks like the input instructions are like evenly separated. I should bump the font size. And it looks like they all read to W. That's also interesting. Yeah, they all read to W variable. and they also look surprisingly similar. Like after the input, it does mul x and 0, add x and z. It's the same here, mod x by 26, which is interesting. This means that it's assigning z to x and then taking the remainder with x and 26. And it does the same here, and then it looks like it keeps doing the same. Oh, here's the difference. Near the end, it adds 6 to y, and here it adds 14 to y. But then it does the same two instructions in the end. So it looks like after each input, things look very similar, like what the program does. And this is basically why I got stuck. I think the last time that I tried this, well, when Advent of Code 2021 was going on, is because I was analyzing this too much. And I guess eventually we'll have to figure out what this program does. What's the meaning of these instructions? Because like brute forcing will probably not work. But I want to try brute forcing first. Write an interpreter for this code and run it, I don't know, for the number consisting of 14 nines, which would be the biggest number. I go down from there and see if anything is valid. I don't think that will work because, well, 14 digits numbers are way too big and we cannot brute force all the possibilities. But I don't know, maybe trying that we can learn something along the way and get closer to an answer, because I have nothing basically. So let's give that a try. Open the terminal. Let's go to projects, Advent of Code 2021. I also have 2020. I think Advent of Code 2020 I actually also completed, if I remember correctly. Yes, this one has this monster puzzle, and I did this one in Ruby. Yeah, it was a lot of fun. But yeah, I want to finish Advent of Code 2021. So let's open the code editor here and remember where we were. Okay, so we have day 25 open for some reason. I don't even remember how I was doing, like what's the structure of this project, but I guess it's probably, yeah, similar to look at this, the main program. I should also bump the font size here. The thing here has an empty closure here for instead of day 24 with a to do. Let's remove this to do and add day 24. Let's add a module called day 24 also, and a file. Let's copy day 23. Call it day 24. Remove everything. So this is just the function run. What the hell? Oh, I don't have input here. This is probably not a good day to have copied. But yeah, I guess when I'm running things, I'm just printing two numbers. So let's print just 5 and 42. And delete everything else. Okay, that's good. How does this thing run? If I do cargo run, release mode, yeah, just run this. Well, still compiles and runs. Here we have the output for day 24. Okay, so not too bad. And how were we reading the inputs? Yeah, okay, so we were doing this include string thing. Let's copy that. Include string. For some reason, this is using like two space indentation. If I read the, yeah, if I open the file again, it's changed to 4. Okay. I don't know, is this project using 2? No. Since I was using 4 space indentation, so I don't know why it was doing that. So not date 22, let's read date 24 and copy the input into inputs, I guess. In file, date 24. Let's copy the inputs. Okay, so we should have the input now. So where should we start? I think the obvious place to start, well, probably the obvious place to start would be parsing these instructions. Which I think, yeah, it makes sense to parse them into some data structure first and then interpret them later, because I will probably want to, if I want to do a brute force thing, trying out many numbers, I would probably want to run the monad program many times. So yeah, parsing seems reasonable. Otherwise, I could also probably read line by line and interpret this thing line by line. But yeah, let's call this thing. Let's do a parse program function that will take an input, let's say string slice, and it will return a program which should be probably a vector of, let's say, instruction. And what is an instruction? Well, probably not a struct. It will probably be an enum of these possible 6 instructions here. So input, add, mul, diff, mod, and equal. Okay, say input. And we will input just a number, right? So let's work with 64-bit numbers and have them signed integers. Well, input is one thing. Then we have add. And when adding, I guess we cannot have just the 2 operands like this, because the first operand can be a variable, and the second one should actually be either a variable or a literal, right? So I wonder if I should do equal like this, or have the different instructions like this, add, mul, and whatever, or have like a generic binary, or I don't know, yes, binary operation thing that has the operation and 2 like operands or something like that. Let's go first with a more obvious thing like this, but actually, yeah, these things cannot be just plain numbers. They have to, like the first operand of this can be the variables x, y, or z, or w, x, y, z, and the second one can be either a variable or a number. So how do we represent that? I guess we can say enum var would be either w, x, y, or z. And if I save, I don't want to do this. I don't like Rust FMT doing this. So I don't know if this is the incantation to make Rust format ignore. Ignore? Come on. Rust FMT skip is what I want. Come on. Okay. So yeah, when adding, we're gonna have a variable, and then basically I want an enum, which would be either a variable or a literal. And how do we call that thing? Maybe operand or something? Enum, operand, which would either be well, a variable, this is not very pretty, or a literal, which a literal will be just a number. Operands. Okay, does this make sense as a schema? I don't know, but let's go with this. So it's add mul div and what? Mul div mod and equal. Okay. And when parsing the program, what are we going to do? We're gonna get the input lines, and we're going to collect the lines into a vector. And then for each line, we are gonna do what? Let's take a look at an example to be shorter. I guess we can split this thing into words. Yeah. Yeah. We can actually do something nice and say something like, no, actually lines is just a method, doesn't receive anything. Let's do map parse instruction. Delegate instruction. And the language server doesn't know how to suggest having one of these. We can have a line as a string slice, and it will return an instruction. Okay, so now we can do what? Line splits white space, I guess, and collect. Let's say words is gonna be a vector, and have this thing, and then do something like match words. We're gonna slice this thing, something like this. And we can have something like input and well, a variable name, and we're gonna do something in this case. Or we could have something like add A and B, but I guess we can also say add or mul or div, oops, or mod or equal, and have this thing captured as, how was the syntax for this? Op? No, not like that. But actually, I will want to. What do I want to do here? I don't know if this is what I want. Well, something like this, an operation in either of these. We can do something else, or otherwise, like if it's any other case for words, I want to say unreachable. Invalid instruction. No, not just the words. Let's just print the line here. And let's have a nice error message here. Why don't you like this? Do you want some parentheses here? Yeah, okay. I don't know if this is a very good idea, but okay, let's see. If they have the input, also when parsing variables, I guess I want to what? This, I could also do something like, okay, variable needs to be either W, X, Y, or Z, but I guess I could delegate that into something like, say, okay, this is gonna return an instruction of input, and parse variable and pass this thing, maybe. And here we can generate the actually yeah, the input instruction doesn't, yeah, no, it doesn't make sense to receive an i64 here. This should receive a variable, so this should return a variable. And yeah, I guess we can do a simple match here. I don't know if using an enum for variables is the best thing here. Let's go with that. So match the variable, and let's say this will return a variable W, and let's copy this 4 times, and we will say something like X, Y, or Z. This would return X, Y, or Z. Okay. Seems good. Now for here, yeah, I probably don't want to match this like this here, because we will have to do another match inside. So yeah. And this probably also should complain about this thing not being like being something else. Well, let's try that. Let's worry about that later. But we are going to have these cases. Let's just simply do this and match the operation, and here we can have the different cases. We can do this and do something different for each operation, I guess. This seems a bit repetitive, but let's go with this. And actually, I would probably want to do something like, okay, let's a must be a variable, so let's parse it. Parse variable a. Okay. And b can either be a variable name or a number, so we can say something like what? If we can try to parse b as a number, so b parse, if it is a number, then we can say then b is gonna be an operand, a literal with this value. Otherwise, we can parse it as a variable. B. No, actually, it would be an operand of type variable with this parsed variable. Okay? And what are you complaining about? The parse is a result. Okay. So now B is an operand and A is a variable. That's nice. And here I guess I can do, let's do a multi-cursor edit here. I think it should work. Here we can return an instruction of type with A and B. And we can uppercase this. Uppercase. Yeah, look at that. And you're complaining because double reference. Yeah. And you are a double reference because maybe I am referencing more than necessary here. Yeah. Yeah. That seems good. Yeah, and now it complains about non-exhaustive matches, which makes sense. So otherwise, this should be unreachable, invalid. Well, I guess it's the same thing as before, right? Invalid instruction. But in this case, it's the operation. Let's use single quotes for this. Why not? Whoops. Yeah. And here you should complain about the same. Unreachable. Invalid variable. Bar. And that's it. We have a lot of unused things, but as soon as we call this parse program with this input, we should have the program parsed. Yeah. Okay. Let's actually maybe print this. Yeah, let's not print. Actually, this doesn't have a return value, so we don't need to print anything. Print line. Well, let's program be this, and here let's just print the program as a nice debug thing, but this probably requires instruction to drive debug, and same thing for operand and for var. And if we run, can we run a single day for this? I don't remember. Yes, okay. So this is very indented. But let's see if the last instructions look correct. Last instruction is an add between Z and Y. Yes. And the second to last, mul Y and X. Yeah. So it looks alright. Which is to be expected. This was pretty straightforward. And now we should add an interpreter for this. So let's remove the debug. Well, actually, let's leave the debug things because we probably need to debug this. Okay. So what do we want to do? What do we want to do? Well, I would actually want to maybe start with some of these simpler programs. Let's say, well, I actually liked this one about printing to, like, extracting the binary bits, but let's start with this one. Instead of parsing this, let's parse this. Oof, that's ugly. Yeah, okay. Let's have this. Not so ugly. And let's do something like, well, run alu program, passing this program, and well, let's print the result of this. Let result be this, and print line these results. Okay. So please generate this function. Oh, that's nice. When you pass this as a reference, it actually takes a slice. I didn't know that. Run alu program. So what do I want this to return? I think I want this to return the 4 registers that this alu has. So this would be 4 64-bit numbers. And this cannot be printed like this. It has to be printed as debug. Okay. Instructions. Oh yeah, we can actually call this program. Why not? So how are we going to do this? Well, I think we are going to need our variables x, y, and w, x, y, and z initialized as 0. This I want to be mutable for sure. And then we are going to just return y, x, no, sorry, w, x, y, and z. Okay. And in the meantime, we're going to do, for each instruction in program, do I need to actually do this? I think if I do this, this has the, yeah. we're going to interpret each instruction. So we're going to basically need a match of the instruction. I'm pretty sure that there is a way to like autocomplete or match cases for this. Ins.match maybe. Well, that was not very helpful. Instruction. Well, what if we have an input and a variable here? Well, actually, we need to also pass the inputs to this run a loop program, right? Yeah, I think so. So what are the inputs gonna be? I guess we can just pass a slice also of numbers, and I guess we can keep an input, well, an input iterator, which will be inputs iter, or into iter, and this should be, yeah, an iterator of numbers. And here, when we have the input instruction, we are going to do, well, input next, and well, we need to expect this. Let's open some braces here, have some room. Let value is going to be this, and if we don't have a next input, it is insufficient inputs for program. I was realizing that the sidebar there was occupying lots of space. I bumped the font size a little bit because I received some feedback about my videos having very small font. So I hope that this is readable now. It's actually a bit easier on my eyes too, so I think I will use this like pretty big font size. Okay, so where was I? Yeah, we are reading what the next input is. So we have this value, and we have to assign this value into one of each one of these variables, depending on the value of this input variable. What's the name? So I'm wondering. I wonder if we can get away with, like, instead of using actually named variables here, can't we have something like, hey, mutable registers or variables? Are these things called registers? Registers? No. They're called variables, so let's call it vars, and let this be just a array of 4 variables, and return this. So if we have that, I think we can simply do vars for var as usize. So we are basically indexing this with the number corresponding to this enum, and we can make sure that this starts at 0. I think this is standard, like the first variable starts at 0, and I guess I can let, yeah, okay, let the formatter do its thing. So we have this. What's the problem? The problem is the for loop expects this. Okay, this should be equal to value. And what's your problem here? The reference. And probably also need some dereference here too. Can we actually match this like this? Cannot be covered. Yeah, but generate. Yeah, thank you. Okay. These are going to be very similar, I think. But this works, right? Why is this complaining? This function takes... okay, it also needs the input. So this was the program that has 2 inputs and checks if the first one is 3 times the second one. So let's pass as inputs I don't know, 5, 3 times, so 6 and 2, I guess. So this should give, say, true in Z, and the X variable should have, sorry, it should say 1 in Z because this is 3 times as this, and value 2 in the X variable after this has been run, I think. Cannot move out of this because this is not copyable. Okay, so I guess we can match like this and the reference here. No, why not? Removing. Can I dereference here? Yeah, okay. Fine. Let's do that for everyone. Oh, there's probably other things that are not copyable. So do I want this to be copyable? I mean, probably, but let's do old school dereferencing and think about that later. So all of these cases, I think they will basically be the same. We need to, like, a lot of the logic in here will be the same. So maybe it is a good idea to have like an operation thing. Yeah, I think so. Well, okay, let's do addition first. So what will we need to do here? Well, we're actually going to do, I think, something very similar to this. Why is this complaining? Cannot move out of bar, which is behind the share. What? Can I not do? Can I do this? What? Cannot move out of this because it's a share reference, yeah, and the thing is not copyable, I guess. Well, you know what? Have your copy and your clone, which is needed for copy. Okay, now it doesn't complain. That is fine. I think we're gonna have to do something similar for this. So yeah, into the A variable. But what is the value gonna be? Well, let's value be the addition of 2 things. We're gonna have, well, A, we know it's a variable, so we can have bars same thing here, a as usize plus, but b is not just a variable. It can be a variable or a literal. So we can do, well, we could do a match here, or we could delegate to another function. So something like, I mean, we have these enums. We could actually have some delegation to the enums themselves, I think. So we could say something like b value. We can pass in the bars here. Generate method. Oh, look at that. That was pretty clever. This should return a value, a 64 value. And here we can say, hey, match self. If we are a variable, then we're gonna do this vars var as usize, I guess. And if we are a literal, you can just return that number. And I guess, yeah, operand. Okay, I don't know if I want this extracted actually. What's your problem here? Yeah, dereference this. What's your problem here? Well, yeah, let's pass this as a reference, I guess. Okay, so we are going to basically do the same for mul, div, mod, and equal, like the same code as this. Probably even inline this. Look at that. It's not that bad. I could probably live with this copy pasted to the different cases, to be honest. We can extract it later. So multiplication is also easy, just multiplication. Division is integer division, so that's also easy. And mod, okay, mod could also be just this, but I wonder if we should do the assertions of A and B not being negative. So when dividing, I guess I want to actually assert that B is not 0. So assert not equal B 0. So let's avoid dividing by 0. And yeah, okay, B. We have to take the value of this. So extract this into a variable. Let's call this just B also. Look at that. So pretty. And for division, we are gonna do something similar. No, sorry, for mod. But in this case, we want to assert not equal. No, sorry, what we want to assert was that A and B are positive, something like that. So what's the condition? especially cautious. Okay, b equals 0, and yeah, a has to be positive or 0, and b has to be greater than 0. So, and b greater than 0. And we're gonna need to do something similar to this. B is gonna be this, and A is gonna be this. So, A. And this is gonna be A more B, mod B. Oh, Okay, let's call this thing then A value. Yeah. And B value. And consistent naming went out the door. All right, and finally we want to do equals. So I think it's gonna be similar to the previous ones. So we're gonna compare this as being equal, and so it was 0 if true. So I think if we do as bool, it's gonna be fine. No, not as bool. This is a bool. So as I64. Okay. Okay, it's not complaining, so let's try to run this. And we have a listen variable x. We do have the 2 that we were expecting. But this also should store in variable z. I thought that it was going to store 6, so maybe we can print something here and see what's happening. Println after execute. Well, after the instruction, it's printed as debug. The variables are going to be these vars. Okay, and this is also debug print. So after input of z, that doesn't look right. Oh, no, it doesn't look right. This is 6, okay. After input of x, this is 2. Oh, and then it's multiplied. So I think I did it the other way around. So it's multiplying z by 3. What did this thing do? Takes two inputs, then sets z to 1 if the second input number is 3 times larger than the first. Okay, the second one has to be 3 times larger. So 2 and 6 it is. And now if we run this, yes, now we do have in z true. So it seems to be working, our little interpreter. If we pass less number inputs than necessary, this should fail with insufficient inputs for program. That's fine. And okay, we have something working. That's really interesting. Now we should try to run this thing with the actual aim-word program. So should we do this? Let's do include stir of inputs slash day 24. How was it called? 24? Yeah, just that. No extension. We can get rid of this input. So we have to run with input of 14 numbers. So let's just can we do something like this? Yes. 14 nines. Let's run. And okay, it did a bunch of things. This is interesting actually as debugging. So what was the variable that we have to check? Set variable. Leaving a 0 in a set variable. So it's definitely not 0 in set. That is the last variable. It is a pretty big number indeed. And it seems to be growing. That's interesting. It's very interesting. So I do wonder if depending on the different numbers, on the different inputs, if some inputs will cause this number set to not grow as large. So we can actually take a look at the input here in the text editor, because this is better than looking in the browser. We can see that if we search for, well, this, can we search for just this thing? No. Multi-line search, come on. Yeah, we do have this thing repeated as we thought. Okay, so maybe I want to brute force this a little bit. So let's try something very precarious and stupid. Let's say something like for a number in, let's go, I guess we could express this in the most stupid way possible. So actually, do we have, I want to see Rust number or integer 2 digits, split an integer into individual digits. I don't want to do to string and chars, come on. But well, I could probably do that. Digits from integer. Come on, this should exist. To convert to string, I'm doing it directly. Okay. Well, we can do the ugly thing for sure. So we can go up to, this is 14 nines, so 1, 2, 3, 4, 5, 6, 9, 12, 15, 14. We can get this and actually reverse this iterator and go back and say something like, okay, let's take the first, and let's be conservative, let's only check the first million numbers, going from the highest to the lowest. And we are going to run the ALU program with some input here. We need to get the inputs. What's your problem here? Out of range, yeah, but you should be an x64, come on, yeah. Okay, what do I want to do? I want to, well, let s be n to string, very ugly. And actually, if the string contains a 0, we're going to continue. We don't care about those numbers. Otherwise, well, we already have this thing converted into string. I guess we can then convert it into numbers, right? So how do we do this? We can say something like we can take the string, we can use the characters or bytes, I guess, as bytes. And then map these things into 64-bit numbers, I guess. Yeah, something like that. As bytes. Actually, as maps does return what? A slice, right? Yeah, slice of bytes. Can we do something like something like have a fixed size for this, like now let's keep this bytes thing. This is a slice, right? We cannot map a slice, no. I want to like convert the slice into a fixed array. Something like bytes, an array of 14 bytes. Can we say something like into not satisfied, or try into? Let's try into a thing. Yeah. Expect. Yeah. Should be a 14 digits number. Okay, it's not going to be that when getting closer to 0, but we we have a long way to go. So does this work? Yeah. That's a very long number. Yeah, so we should have the bytes here, and then we can have let inputs be the bytes mapped. So we can do byte minus, I guess, the byte corresponding to 0, right? So this should be 0 for 0, and 1 for 1, and so on, up to 9. Yeah. And here we can pass a reference to these inputs. You don't like this because oh yes, this as I64. Okay, we're gonna have the result, and we're gonna say something like if result on the set variable, which is the fourth one, is 0, then it's valid. I think it was like that, right? Yes, it's valid if it's 0. So let's actually say, hey, it's valid. If it's valid, then we are going to print fine. Model number is valid. And the model number is S, basically, or well, S or N is the same thing. And then we are going to break out of this loop. Okay. Actually, I want to probably, let's see if we did this conversion right. So I want to just take the first one, and here let's print the inputs before running. Print line inputs are inputs. Do we still have, yeah, we have all this debugging. Oh, the inputs were actually, why did it start with 8? Oh, because it's not, doesn't go up to there, it has to be up to or equal. Okay, but yeah, it seemed like the conversion was fine. We can get rid of the printing inside of the interpreter. Here, let's get rid of this. Let's take 100 and see if we are going down reasonably. Yes, okay. Yes, this looks fine. And let's then get rid of this printing altogether. And let's actually run this for 1,000,000 numbers. Whoops. Okay, and let's run not in release mode to check if there's any overflow or anything. Okay, so it seems like in the first 1,000,000 numbers there is no valid model number, which is, well, kind of to be expected, I think. Maybe we can run for 10 million and do it in release mode so it's faster, and see if in the biggest 10 million numbers there is any valid no. So okay, maybe another approach would be removing this take and letting this thing run indefinitely and going to sleep or something and see if I get any result. Like that is, I mean, that's a possibility. Not a good one, but we can let it run for a bit and see if we get an actual answer. I don't expect that we do, because we probably have to, as the description says, figure out what monad does. We probably need to figure that out. Yeah, we're not getting any answer unless I did any mistake here in the logic of checking this, which is also possible, or in the logic of the interpreter. Yeah, we're probably doing something. Oh, actually, maybe before ending this session, I want to try out this other program too. The one that is, so let's, the one that's a bit more interesting. So let's change this to input and let input be this more interesting program. Okay. And well, let's also comment this. Let's actually move this down. And I want to try out this simple program. Let's do print line of run alu program of this, and the inputs shall be, so this thing I think read a single input and like converted this thing to binary. So let's put a number here, maybe this is 4 bits, so I guess we can go with I don't know, 17. So it should be a 1001 if I'm not mistaken. What's your problem here? Yeah, let's print it as debug. And the program, yeah, let's pass it as reference. So if we run this, no, so this is 1, 2, 4, 8. Sorry, I'm stupid. I don't know binary. So 8 should be 100. So let's say, I don't know, 10 or 9. 9 should be 1001, right? If we run this now, yes, it is 1001. So we seem to be doing division and module correctly. So that's encouraging, I guess. I'm also surprised that this didn't break the parsing, because we have some white space in the beginning there, but it seems to, yeah, not care about that. So, okay. Yeah, I think this is basically what I wanted to do in this session. Also, I didn't want to go overboard with time here, because I noticed that when I program for too long, I start to get very mumbly and tired. So yeah, we have to figure out something, like how this monad program works actually, which is like between each of these inputs, what's happening. We noticed that there's a lot of similarity between each of these. So we can maybe try to understand what's the thing is doing. The mod x26 is also interesting, because this means that there is something that is keeping x at bay and only taking the remainder of this. Is there any other mod? No, it's always, and I think it's always mod x26, right? Yeah, there's 14 of these. So being maybe a multiple of 26 is important. And look at this, then is adding 25 here, which is 1 less than 26. That's interesting also. So there must be some conditions, as some things here. Yeah, it's asking if x equals 0. Yeah, this is quite interesting. 13, which is half of 26. Yeah, we'll have to like figure out what this thing is actually doing some way to understand. So one idea of doing this is maybe following one of the executions, like line by line, and seeing what's going on. Another idea could be, like in Advent of Code 2022, there was a puzzle that was like implementing like a calculator some way, but like an inverse calculator, like a, how do you call this, equation solver or something like that. but they were like simple equations where you could do like replacement of each variable into like the equation that it was needed, and there was never a case where the same variable was used multiple times on an equation. So it was, you can do that in a single loop. But you know, you can probably do something similar for this and say something like, hey, you have you have basically 14 variables for the 14 different inputs, and then you have something like, okay, you also have like x0 or like the initial values of each of these registers or variables, like w0, x0, and y0 and z0 are equal to 0. Then you can say something like, okay, x1 is x0 times 0. x2 is x1 plus z, and like having like a system of many variables, and then use some sort of like variable system solver to solve for all of those equations. Sorry, I said a system of variables, a system of equations. And you know, convert, because this is basically imperative. We are always adding and multiplying with x, for instance. It seems like x is the most used variable here. But you can also think of, okay, this is a new variable x, I don't know, x3, which is equal to x2 times 26, and you know, having separate variables for each of these, and then at the end of the 252 equations, you're going to have something like, okay, z, I don't know, 42 is going to be z 41 plus y, and then the last equation would be something, okay, you know, you want to resolve for z 42 or whatever this number of z is equals 0, and then, you know, solve for that and see what possible values could the different inputs have. That's also kind of I have no idea how to implement like a generic equation system of equation solver, but I know that there are software that does exactly that, so maybe that's another idea. And I don't know, maybe yet another idea is to go with pen and paper and try to understand what this code does a bit better. But yeah, well, what I bet is that these different digits in the input, they will require to be some, you know, some specific numbers, because the first input, which corresponds to the I guess the first one did correspond to the highest, right? I don't remember that actually. Lowest. Most significant. Yeah, here. In order of most significant to least significant. So yeah, the first inputs. Yeah, should be the most significant numbers, and I think we did that correctly. But you know, going like brute forcing this backwards, like we're doing now, we're never going to reach like this number changing. So if this number cannot be a 9 for some condition that we are not understanding, then we are not going to reach this with this brute forcing. So yeah, that's basically what we had to understand. But I mean, that is basically what I wanted to do in this video: have some parsing, some interpreting, and something running. And I'm going to continue this later. I can probably do a little thumbnail for this. So let's say toilets. What did we do today? We did Advent of Code 2021, MWord puzzle part 1. And how was the font called? SM Mono 12. Look at that. Okay, that's, I think, the thumbnail for today's video. And yeah, if you have been, thanks for watching and see you next time. Bye bye.